In this short tutorial video, we will look in detail at the constant bandwidth frequency decomposition method as part of the standard frequency decomposition and RGB color blending workflow available in GeoTeric. The constant bandwidth is a short-time Fourier transform-based technique which utilizes bandpass filters to carry out the decomposition with properties similar to that of a fast Fourier transform. It is accessed within the frequency decomposition workflow, which can be found under the Reveal tab. The first step is to choose a time slice or horizon for our frequency decomposition to be previewed on. We then move on to parameterizing our frequency decomposition. First we generate our frequency spectrum, which is measured around our time slice or horizon which we selected previously. We can then start to look at the different frequency decomposition methods available to us. The constant bandwidth is a great reconnaissance option since it provides excellent frequency resolution and is fast to process. However, it tends to lack the vertical resolution of other techniques available. The table shows the specifications of the defined frequency filters. On the left, we have the central frequency, followed by the bandwidth in Hertz, and the filter length in samples on the right. When using the constant bandwidth method, both the bandwidths and filter lengths are the same for all of the frequency bands. Due to the relatively narrow bandwidths, a high frequency resolution can be achieved. However, there is a trade-off against temporal resolution. Since the filter lengths are larger than for other techniques, there is a greater amount of vertical smearing seen in the end result. The filter length is controlled by the minimum frequency set. A low minimum frequency will require a longer filter length to sample. If this is increased, a smaller filter length can be achieved. The bandwidth scale can also impact on the filter length. A narrower bandwidth will require a longer filter length and vice versa. If we move on and process the result, we can go to the RGB blending window. Here we can assign 3 of our defined bands to an RGB or red, green, blue color blend. A preview of the color blend will be generated on our selected time slice or horizon. This can be optimized depending on our objectives and then processed to the project window. As a result of the good frequency resolution in the constant bandwidth technique, we see a very good color discrimination in the blend. However, if we look at a section through the blend, we can see that there's substantial vertical smearing. Therefore, the constant bandwidth is usually used for reconnaissance type scenarios.